Okay, good evening, everyone. We will start our class today. Previous day we have described about detection or identification of four functional groups. Am I audible to you? Can you hear me,
Yes, ma'am.
students? Okay. So today we will see first the demonstration. I have downloaded two or three videos regarding the test. And you have already done two classes, maths, and before that. So let's just calm down your brain and just see the demonstration via this video tubes, and that will give you some sort of uh, visualization how the reactions or how the identification goes on. Okay, so I will share my screen and you will just watch the videos in Google Classroom as discussed by our HOD today, that F1 batch will have classes from next week onwards, and on Monday from 11 to 12:30 p.m. and Tuesday from 11 to 12 p.m. Am I right? Rajrupa, have you joined? Okay, Rajrupa, the seer of your batch, we have discussed with our HOD that Monday and Tuesday your batches will have chemistry lab. We have 2 hour 30 minutes of lab in offline classes. So we will try to maintain at least 2 hours 30 minutes in this uh, Wavex class also. So Monday will be classes scheduled on 11 a.m. to 12:30, 1 hour and 30 minutes, and Tuesday another 1 hour will be there. That will be scheduled also from maybe 11 or 11:30 to 12:30. These two classes they will be based on your lab, and in Google Classroom we will then in this next we will create a Google Classroom that will not be the official classroom of TIU, as our HOD sir has discussed that we will take our class via Google Classroom, and assignments will be given accordingly. We will share a code and that will be different from that official one. So I'm just waiting for another 4 minutes, and after that I will start the video because 10 minutes after we will start the video. Here we will see the procedures for identification of carboxylic acids, aldehyde and ketone. Now, previous day I have only discussed about test of aldehyde ketone 2,4-DNP test for both carbonyl group aldehyde and ketone. Then for aldehyde group we have seen the failing test, and for ketone functional group we have done the sodium nitroprusside test discussion. But in this video there will be two more tests, that is Tollens reagent test and another one sheaf based test. So in lab we prefer to do phenol failing solution test because that is more available reagent in the lab. In Tollens reagent we need alkaline AgNO3 solution. That is a costlier solution. So silver mirror test is also a very good test for aldehyde identification, but we prefer to do it failings reagent test because it is more cheap solution or reagent that is available in our lab. So you just go through the process or video demonstration, just get the visualization how you can detect by simple qualitative identification of the function. Okay, 23 people have joined. Ramojit Rajupa, still module, the year of. Let's start. I'm just sharing my screen and then we will switch over to YouTube, and where we downloaded the video. We'll see the. Yes. Okay. So first we are going to detect the test for carboxylic acid. People, can you see my video? Come on, please respond.
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Uh, Video is visible to you, right? Okay, so I'm sharing my screen. Just go through this video. Watch this. So, uh, watching this video, we have seen that they added solid sodium bicarbonate to the organic functional group. And we have said that we will take saturated solution of sodium bicarbonate. So there will be no such difference of taking solid sodium bicarbonate directly to the test for adding saturated sodium bicarbonate. In both the cases, effervescence will be seen. Clear? Someone response, please.
Yes, ma'am.
Is the test clear? Okay, so brisk effervescence that you have seen, we can see that bubbles forms in the sphere of the test tube, in the body of the test tube. So it's very good test to detect the carboxylic functional group. Okay, next test, the confirmatory test that we have said that esterification state, fruity smell of ester will be found. Another, the coming test is regarding this one. So let's start. the smell of ester. That means acid and alcohol reacts to give you ester. So if we hydrolyzed ester in basic medium or acidic medium, it give or reverts back the alcohol and acid. In this reaction, we are taking alkaline phenol. But what I have seen through YouTube, there is such hydrogen reaction. That reaction they are showing is based on physical chemistry based practice. That rate determination of constant of rate constant determination of ester hydrogen. That is organic functional group detection test. So I have not seen suitable video for determination of functional group of ester. That is why I can't give a demo video for ester hydrolysis. It's just as simple as that. Uh, you are taking phenolphthalein in NaOH, then you are adding the organic functional group to that little amount of alkaline phenolphthalein solution and shake the solution. And phenolphthalein is an acid base indicator. It is pink in basic medium. So when ester is added to that basic medium, ester will get hydrolyzed by base and it will get you back the salt of carboxylic acid and alcohol. So carboxylic acid is acidic in medium, base is hydrolyzed by the ester. There will be no traces of base in that medium. So pink color of phenolphthalein will change to colorless. That is the simple reaction for hydrolysis of ester. But here I have not found any kind of ester hydrolysis reaction. I am just showing you a picture on which we can see what type of reaction you can have with ester hydrolysis.
Hello.
Yes, can you show this image? This way you have to write down the test for carboxylic acid and for ester as well. So this is the way you will write down the reaction, the experiment, then the observation. In this observation column, you will write down the um, required chemical reaction and the inference. So next we will start the demonstration video of carbonyl functional group detection. And this video is a longer one because it contains a lots of uh, stepwise functional group detection tests. So it takes more than 10 minutes. So next we will see the video of carbonyl functional group detection. Okay, so I'm sharing my screen with you. Just switch over to and the demo. So what in this video is saying? First we will test for carbonyl group and then the respective aldehyde group and ketone group. Is the video is clear to you? Someone please respond. Can you see the video clearly?
Yes, ma'am.
Okay. This yellowish reddish orange crystal is the 2,4-dinitrophenylhydrazone. The C double bond O in carbonyl group condensed with the hydrazine H2 and give you that molecules, that is pH CNH double N double bond 24 DNP. Okay, so that is the reddish orange crystalline, not muddy PPT. It is crystalline. Shiny crystals can be seen in this reaction.
ক্যালেন্ডারটা
So this spelling test we have discussed in lab in previous day
হ্যালো
Webex class. And yes,
হ্যালো ম্যাম কিছু শোনাচ্ছে
can
না
you
অনেক
hear
কিছু
me?
শুনতে পাচ্ছি না ম্যাম কিছু শোনাচ্ছে না
তোমরা ভিডিওটা দেখতে পাচ্ছ না?
ভিডিওটা দেখতে পাচ্ছি ম্যাম কিন্তু এর আগেও আপনি যে কিছু বলছেন কিছু বুঝতে পারছি না ম্যাম ক্লিয়ারলি আসছে না অনেকবার
আমি
কাট কাট করে আসছে
এর আগে আমি খুব একটা কিছু বলিনি ভিডিওটা চলছিল যখন সেরকম কিছু একটা বলিনি।
ভিডিওটাও কিরকম হেজি টাইপের আর
আর ভিডিওর
কেটে
আগে
কেটে
যে আপনি
আসছে।
বলছেন
Actually
অনেকেই শুনতে পাচ্ছে না
ভিডিও বিটরেট খুবই কম।
ভিডিওটা হচ্ছে লিঙ্কটা তোমাদের আপলোড করে দেওয়া হবে গুগল ক্লাসরুমে। এখানে জাস্ট ভিজুয়াল ডেমনস্ট্রেশনটা দেখানো হচ্ছে। ভিডিওটা ডাউনলোডেড বলে এটার কোয়ালিটিটা একটুখানি তোমার মেগাপিক্সেলের উপর ডিপেন্ড করে, তো ডাউনলোডেড ভার্সনটা একটু কম থাকে, তো তার জন্য এরকম হচ্ছে। তো এটা যেটা দেখালো কার্বনিল গ্রুপের ফার্স্ট টেস্ট আমরা ডিসকাস করেছি। উই হ্যাভ ডিসকাস 2,4-DNP টেস্ট দ্যাট কনফার্মস বোথ দ্য প্রেজেন্স অফ aldehyde and ketone. But in failing test, ketone is not responding, only aldehyde response, and failing test is the test in which equal mixture of failing A, copper sulfate, alkaline copper sulfate, and failing B, sodium potassium tartrate with organic sample is heated in a test tube in water bath for 5 minutes, and after that copper oxide, that is cuprous oxide, red precipitate of cuprous oxide is formed in the B test tube. So this confirms the presence of aldehyde. This is the failing test. And previous test was tolerance reagent, that is alkaline silver nitrate solution, and we give silver mirror because of the precipitate of Ag from the solution, and it gives you a shiny mirror type of uh, reflection in the test tube. That is why it called as silver mirror test, and that is also given positive by aldehyde, not by ketone. So these two tests is very important for detection of aldehyde group. Shift base is also a base which confirms the test, but in lab we prefer to do the failings test first, and then we prefer to do the silver nitrate test, the silver mirror test, as it is a very costly reason. Silver nitrate is very costly, so we prefer to our students to failings test reaction. Okay, next we will check out the test for ketone function. So this is the way we detect the test. Now tell me one thing. How many labs have been done in university in offline mode? F1 both batches. 2 or 3.
Ma'am, 3.
2 or 3 labs. Viscosity lab has been done here. How many labs have been taken in your offline mode?
Ma'am, group 2, 3 labs.
Group 2 clearly बोलो.
मैम 3 लैब হয়েছে
Batch A, both batches. Batch A, batch B, both batches have done 3 labs, right? Yes or no? Batch A and batch B both has done 3 labs. Surface tension, viscosity, acid-base titration. These 3 labs has been done in your university.
yes ma'am
You are conducting
Yes,
classes
ma'am.
for both the batches, right?
yes ma'am
Okay. So this is the fourth one. So now we will start some kind of discussions. The video is actually the general overview how we detect, how we can identify. But here are some questions that can be asked in Viva or that can be given in your Google Classroom assignment. That phenol is phenol. All of you know phenol, the structure of phenol. Please respond. Phenol C6H5OH.
yes ma'am
Yes, ma'am.
So we can ask explain why carboxylic acids or carboxylic acid is more acidic than phenol.
ma'am your voice is not coming
You can see the whiteboard. Can you see the whiteboard?
Yes, ma'am.
Okay.
yes ma'am
Explain why carboxylic acid is more acidic
ম্যাম
than
ম্যাম
phenol.
প্রত্যেকের কথা ডবল করে আসছে
ইকো হচ্ছে ইকো
সেটা আমি দেখছি।
কিচ্ছু বুঝতে পারছি না
Wait one second.
হেডফোন ইউজ করলে ভালো।
I'm using headphones,
I'm using headphones,
but I don't know why this
but I don't
problem is
know why this
occurring.
problem is occurring.
So I'm sharing
So I'm sharing
the whiteboard.
the
I'm getting
whiteboard. I'm
writing
getting
the
writing the
questions that can be
questions that
asked.
can be asked.
The first question was why phenols are less acidic than carboxylic acid. I think this time the voice is not duplicating. Am I audible?
Yes, ma'am. You're audible.
Okay.
Okay.
Now, acetic acid and
Now,
formic acid.
acetic acid and formic acid.
So, acetic
Ma'am,
acid is
Acetic acid
typical
is
and
typical and
hello.
আবার হচ্ছে
yeah,
Again, it has started, ma'am.
I'm getting confused why this is happening. But I think when two or more people talks together, then this voice duplicating comes. So when I alone speak, I think now the voice is not duplicating. So here we see the question acetic acid and formic acid. The structure of formic acid is HCOOH. Formic acid structure. This is formic acid. And acetic acid is CH3COOH. Okay. So in this molecules, we can see that CH3 group, that is the alkyl group, has plus I effect, inductomeric effect. I means inductomeric effect. But H does not have such effect. So when, according to Brownstedt-Lowry concept, a acid is a molecule which can gives up a proton, right? Clear? Am I audible? Students, can you hear me clearly? Someone responds?
Yes,
Yes,
ma'am.
ma'am.
Okay. According to Brownstedt-Lowry concept, the acid is a substance which gives a proton, or it can be defined as a proton donor. And the base is a substance which accepts the proton, or it can be defined as proton acceptor. So acidity comes from carboxylic acid. We have C double bond O, OH, in which O minus, that is the carboxylic acid the O minus group, and in acetic acid CH3 group has a plus I effect which gives the carbon a positive charge, and in formic acid H does not have this type of negative this type of electron repelling characters. So what happens when we get carboxylate ion, whether it is formic acid or acetic acid, the H is directly attaching with COOH group. So it does character like alkyl group. That is why the COO minus charge is stabilized more, and it is more strong acid than the acetic acid. In case of acetic acid, the acidity of the compound carboxylate anion get decreased. But in case of formic acid, it is higher because of the absence of electron repulsion character in H group than that of CH3 alkyl group in acetic acid. So this type of questions can be asked. Another type of questions that can be asked. Okay. Next questions can be asked. Which one is stronger? Chloroacetic acid, dichloroacetic acid, or trichloroacetic acid? Here we can see in trichloroacetic acid, that means all the hydrogen group in alkyl group is replaced by 3 chlorine atoms. In dichloroacetic acid, 2 hydrogen group in CH3 is replaced by 2 chlorine atoms. And in chloroacetic acid, only 1 H group is replaced by 1 chlorine atom. So we know that in case of halogen group, that means fluorine, chlorine, bromine, iodine, these 3 are electronegative atoms. That means it attracts electron density towards itself. So when one chlorine atom is attached with acetic acid, it forms chloroacetic acid, replacing one hydrogen atom from this CH2 group. It repels electrons towards itself, and the negative charge over O minus get into the resonance and it gets stabilized. So it has more acidic nature than normal acetic acid. Clear? Cl is electronegative atom. It attracts the electron cloud towards itself. So it enhances the stability of carboxylate anion by attracting the electron cloud towards itself, and that is why chloroacetic acid is more acidic in nature than normal acetic acid. So when we attach 2 chlorine atoms, dichloroacetic acid, the acidity will be enhanced. Similarly, in case of trichloroacetic acid, the acidity will be more. So this type of question, which one, chloroacetic acid, dichloroacetic acid, or trichloro, which one is stronger? So the answer will be trichloroacetic acid. Next question can be asked, compare the acidity between chloroacetic acid and normal acetic acid. Or we can ask by replacing the chloro group by nitro group. Nitroacetic acid or normal acetic acid? Which one will be stronger acid? Chloro, nitro, these all have minus I effect. It attracts the electron cloud towards itself. So this type of questions can be given in your assignment, because in case of offline mode, we can ask that answer the or draw the diagram of benzoic acid, chlorobenzoic acid, metachlorobenzoic acid, or parachlorobenzoic acid. But in case of Google Classroom, we cannot ask you this type of questions, because you can copy paste from the internet and you will put. At Viva, we have face-to-face interaction. So we will give you some kind of questions that you need to use some analytical power. Based on that type, we are asking you the question. So the first question we have asked you, I have asked you that carboxylic acid is more acidic than phenol. Right? Someone responds, please. And the first question, explain why carboxylic acid is more acidic than phenol. That was the first question. This was the first question, why carboxylic acid is more acidic than phenol. So in this case, the strength of an acid depends on the stability of its corresponding conjugate base. We can say the strength of an acid depends on the stability of its corresponding conjugate base.
Please repeat the line.
The strength of an acid depends. The strength of an acid depends. Write down the answer. The strength of an acid depends on the stability of its corresponding conjugate base. Conjugate means base means RCOOH. It is an acid. Its conjugate base is when it gives up the proton and becomes RCOO minus. That is the carboxylate anion is considered as its conjugate base. For case of phenol, the phenoxide ion is considered as the conjugate base of phenol. C6H5OH is the structure of phenol, or PHOH is the structure of phenol. So when H is removed from the molecule, C6H5O minus comes as the conjugate base of phenol. So the strength of the acid depends on the stability of its conjugate base. The higher the stability of the conjugate base of an acid, the higher it is acidity. So generally it depends on the number of possible resonating structures. Carboxylate anion, in carboxylic acid we have CH2C double O minus. So this minus charge is delocalized over two oxygen atoms in carboxylic acid. This negative charge is delocalized over two oxygen atoms. If we can see that CH2C, within bracket I have given the negative charge minus. This minus charge is delocalized over two electronegative oxygen atom. Here, can you see it? CH2C double bond O. We can I'm using the pencil, but it's not working so nicely. So this minus charge in carboxylate anion is actually spread over two oxygen atoms. But in case of phenol, that phenoxide ion O minus, this is a phenoxide ion O minus. In case we see that the resonance is also disturbed and it comes out as the negative charge on the less electronegative carbon atoms. If we draw the resonating structure, it's very difficult to draw the resonating structure on this whiteboard because the pencil is not responding clearly. We can see that the negative charge comes over with less electronegative carbon atoms over benzene ring. So that is not a stabilized one. The corresponding conjugate base is not stabilized like the corresponding conjugate base of carboxylic acid. That is why carboxylic acid is stronger than phenols, or in case of alcohol, this thing happens. ROH, if we remove the hydrogen, it comes as RO minus. R is directly the alkyl group attached with oxygen. There is no sp2 hybridization, only sigma bond is there. So that is why the conjugate base RO minus is not stabilized. So carboxylic acid acidity is higher than that of phenol or alcohol. So we can see that, for example, in case of corresponding conjugate base of phenoxide ion, the stability of the conjugate base in you can write down this line. The stability of the conjugate base in carboxylic acid is stronger because the delocalization of negative charge in the carboxylate ion involves the structure of identical energy where the negative charge is localized on electronegative oxygen atom.
We can't follow you. Can you please repeat the line?
Write down the delocalization of negative charge in the carboxylate ion involves the structures of identical energy where the negative charge is localized on electronegative oxygen atom.
Structure of
Identical energy. We can get two identical resonating structures of carboxylate ion. Identical energy where the negative charge is localized on electronegative oxygen atom. But in case of phenoxide ion, although the number of resonating structures are greater than carboxylate ion, but the negative charge is delocalized on less electronegative carbon atom. On less electronegative carbon atom. Which results higher energy content and is less stable than carboxylate ion. Can you see the image that is I'm sharing? Here we can see that acidity increases from alcohol to phenol to carboxylic acid. Here, the conjugate base of the corresponding acids is respectively RO minus, PHO minus, RC double bond, O minus. Like I said, the canonical forms for phenol. Can you see the image? Someone responds, please.
Ma'am, we can see.
The canonical forms of phenol, this one, phenoxide, is highly resonance stabilized, but the negative charge comes over the less electronegative carbon, right? But in case of carboxylate ion, the negative charge comes over the more electronegative oxygen atom. So we can say that higher the negativity or higher the delocalized negative charge is over the oxygen atom, higher the strength of its conjugate base stability. That is why the base conjugate base is more stable, the higher is its acidity. In PHO minus, we can lost aromaticity as well as the negative charge comes over the less electronegative carbon atom. That is why phenoxide ion is less stable than carboxylate ion. So we can say that carboxylic acid is higher negative, higher acidic or more acidic than the phenoxide ion. This type of questions can be asked. Okay, or chloroacetic acid, monochloroacetic acid, dichloro, trichloro, this type of question from acid base. Next, we can say ketone or aldehyde. Ketone aldehyde differentiation test, tolerance reagent test, silver mirror test. We can say that in assignment, write down the balanced reaction of 2,4-DNP test. It is a condensation reaction or addition reaction. What kind of reaction is this? So it is a condensation reaction. Next, bisulfite test. This type of questions regarding the theory, or we can ask you what is the structure of or acidity of parachlorobenzoic acid and orthochlorobenzoic acid. Compare the acidities between these two, parachlorobenzoic acid or orthochlorobenzoic acid. These type of questions can be asked from this viva, from this experiment. So today I'm just discussing because I will next week attach the assignment to the Google Classroom. Next question, I'm sharing the content with you, and you can see that. That is, write down trichloroacetic acid, write down trichloroacetic acid, dichloroacetic acid, or chloroacid. Which one is more acid?
Ma'am, can you please be louder? Can't hear you.
Trichloroacetic acid, dichloroacetic acid, and chloroacetic acid. Which one is more acidic? See the structure. Trichloroacetic acid pK value 0.66, dichloroacetic acid 1.25, and chloroacetic acid 2.85. The structures of conjugate base you can see from the picture. This is the structures of conjugate base, and the negative charge of the conjugate base stabilized, as I said, by the minus I, that is inductomeric effect by or inductive effect by chloro group, which is higher in Cl3, trichloroacetic acid, Cl3COOH. So the conjugate acid stabilization explain the strength of its acidity. So minus I effect for 3 chlorine groups will be obviously higher than 2 or 1 chlorine group. That is why trichloroacetic acid is more acidic in nature than normal chloroacetic acid. If it was CF3 in place of chlorine, if it was fluorine, the acidity will be CF3. Trifluoroacetic acid will be more acidic in nature than trichloroacetic acid, right? Because fluorine is more electronegative, the most electronegative atom in periodic table. So that is why trifluoroacetic acid is more acidic than trichloroacetic acid. So HCOH, formic acid, acetic acid, phenol acetic acid, trifluoroacetic acid, or normal trichloro, dichloro, monochloroacetic acid. This kind of acidity comparison can be asked in assignment. That is why I'm generally discussing this type of questions, okay? That you can analyze and then write which one will be more acidic, and just simply write in 1 or 2 words what is the cause of this acidity nature in the molecule, what causing the driving force. So this type of questions is asked in assignments. Next we can ask that benzaldehyde or acetaldehyde. Benzaldehyde means PHCHO, right? And acetaldehyde is CH2CHO. Benzaldehyde, acetaldehyde structures, or we can ask benzophenone, structure of benzophenone, acetophenone. Acetophenone structure, what is the structure of acid and benzophenone? Structures of acetophenone and benzophenone. Acetophenone is only one pH group, and in benzophenone we have two pH group. That means C double bond O is for one. One stands for ketone, and the two hands of carbon is free. That is replaced by alkyl or phenyl groups. So in case of acetophenone, we get PHCOCH3. PHCOCH3. Acetophenone is structure of acetophenone structure is PHCOCH3. And benzophenone is C6H5CO6H. So this type of question we will ask. I think this is enough for this identification of functional groups. ketone, aldehyde, formic acid, and ester. In case of ester, we get some organic esters or some organic acids like lemon contain citric acids, apple contain malic acid, ta- tamarind contain tartaric acid. This type of organic acids examples can be asked. So you have to say what kind of organic acids. Saponification of ester is very much useful for determination of rate constant for ester hydrolysis by ester hydrolysis. So I will take a snapshot or attendance. 36 students. I think we will finish this class. How you have to write down the lab copy? You just start writing it for known reactions of these 4 reactions and keep a space blank for unknown samples, and then we can give you a name of a compound. Suppose we can say write down uh, orthochlorobenzoic acid test. So what will be its positive test, or ortho nitrobenzaldehyde. This type of test we can give you as unknown functional group. So you will write down the test, what will be the positive and negative test. Now I will finish this class. Anyone have any doubt? Next day we will discuss about the hardness of water.
What did you tell about the
Determination.
lab copy?
Lab copy, you just start writing the lab copy as the known sample. I have sent the lab manual to Rajrupa. Did you get that?
No, ma'am.
I have sent the, and in this lab manual, the instructions are written over line by line. But in lab copy, you have to write it in columns.
ম্যাম
Column 1 contains experiment. Yeah,
ম্যাম
বলো
ম্যাম বলছি আমাদের ল্যাব কপি তো ম্যাম হস্টেলে রয়ে গেছে।
কোথায় রয়ে গেছে?
হস্টেলে যারা ওখানে হস্টেলে রাখতাম ওখানে ওখানে অনেকের তো আছে যারা হস্টেলে ল্যাব কপি রয়ে গেছে।
ও, তাহলে এক কাজ করো, তোমরা যদি পারো তো রাফ শিট যেরকম আমরা মেনটেন করতাম ল্যাব কপিতে, তোমাদের সেইভাবে একটা আলাদা শিটে এক্সপেরিমেন্ট গুলো লিখে রাখো। যখন কপি তোমাদের সাবমিট করতে বলা হবে ওই শিট গুলো অ্যাটাচ করে দেবো ওর সাথে।
আচ্ছা ঠিক
ঠিক
আছে
আছে?
ম্যাম।
আই
ওকে
থিঙ্ক
ম্যাম।
যেহেতু তোমাদের মানে নিট আর জয়েন্ট এন্ট্রান্স 26 জুলাই অ্যানাউন্স হয়েছে, তো আই থিঙ্ক
হ্যাঁ
তার আগে নিশ্চয়ই কলেজ খুলে যাবে, তো আমরা নিশ্চয়ই ক্লাস নেওয়ার বা অ্যাটলিস্ট কপি সাবমিশনের তো সুযোগ দিতেই হবে স্টুডেন্টদেরকে। তো তোমরা ল্যাব কপিটা রেডি রাখো, ঠিক আছে? নেক্সট উইকে
ঠিক
আমরা
আছে।
ডিসকাস করব হার্ডনেস অফ ওয়াটার রিলেটেড এক্সপেরিমেন্ট। হোয়াট ইজ হার্ডনেস, হার্ডনেস অফ ওয়াটার কিভাবে ডিটারমাইন করব, এটা নেক্সট উইকে আমরা পড়বো। নেক্সট উইকে ক্লাস তোমাদের থাকবে হচ্ছে সোমবার সকাল 11টা থেকে। রাজরূপার সাথে আজকে ডিসকাস হয়েছে তোমাদের রুটিনটা মঙ্গলবার আর সোমবার থাকবে। সোমবার সকাল 11টা থেকে ক্লাস থাকবে, মঙ্গলবার হচ্ছে 1 ঘন্টার ক্লাস থাকবে 11:30 থেকে নিবে। তো আজকে আমি
12:30।
এখানেই ফিনিশ করছি। মঙ্গলবার 12:30 থেকে ক্লাস,
হুম।
আর সোমবার 11টা থেকে 12:30, তাই তো?
হ্যাঁ হ্যাঁ।
ওকে, মঙ্গলবার 12:30 থেকে 1:30। তো আমরা নেক্সট উইকে ডিসকাস করব হার্ডনেস, হার্ডনেস অফ ওয়াটার কিভাবে ডিটারমাইন করব, তারপর হোয়াট ইজ কমপ্লেক্সোমেট্রি, এই এক্সপেরিমেন্টগুলো আমরা নেক্সট উইকে ডিসকাস করব। তো যেভাবে আমরা এখানে ইমেজ দেখছি সেভাবে ইমেজ কিছু ফার্স্টে ডিসকাস করে নেক্সট ভিডিও ডেমনস্ট্রেশন, not exact demonstration we can give like lab, because অনেক এক্সট্রা ইনফরমেশন বা কম ইনফরমেশন থাকতেই পারে সেই ভিডিওতে। যতটা পারা যায় ভার্চুয়াল ল্যাব কেমিস্ট্রির ক্ষেত্রে ততটা করানো হবে। 2.5 ঘন্টার ক্লাসটা যেহেতু আমাদের কভার আপ করতেই হবে। এখানে একটা প্রবলেম হচ্ছে যে স্টুডেন্ট টু স্টুডেন্ট ইন্টারাকশন যেটা আমাদের ল্যাবে হতো ফেস টু ফেস, সেটা হচ্ছে না, যার জন্য কিছু প্রবলেম, কিছু টেকনিক্যাল ইস্যুস আসছে। বাট যতটা সম্ভব আমার পক্ষে আমি দেওয়ার চেষ্টা করব। গুগল ক্লাসরুম আমরা শিডিউল করে নিয়ে তারপর অ্যাসাইনমেন্ট ওর মধ্যে তোমাদের আপলোড হয়ে যাবে, সেখান থেকে তোমরা অ্যাসাইনমেন্ট করো। তো আজকে আমাকে রাজরূপা স্ক্রিনশট পাঠাও,
হ্যাঁ হ্যাঁ
নাম্বার অফ স্টুডেন্টস 36 ছিল, সেটা 30 হয়েছে। তো এরকম ক্লাস করতে অনেকেরই হয়তো ভালো নাও লাগতে পারে, বাট কিছু করার নেই। তো আমি আজকে মিটিংটা মানে
ঠিক আছে ম্যাম, থ্যাংক ইউ ম্যাম।